Here we have an important observation. So objective, the general solution. Well, let y sub p be the particular solution of a differential equation, and it's in non-homogeneous form. And suppose the set including y1, y2, y3, and yn be the fundamental set for the homogeneous differential equation associated to that particular solution for the non-homogeneous form of the differential of the same differential equation. Then we can write the general form of the solution for this differential equation this way. Then y equals to c1 y1 plus c2 y2 plus dot 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 cn yn plus y sub p is the general solution for the non-homogeneous differential equation on the given interval C. Remember that if you have more particular solutions, you're going to add them to the right-hand side of the general solution. For example, consider this differential equation. Here we have the third derivative of y minus 6, the second derivative of y plus 11y prime minus 6y equals to 3x. Suppose for this non-homogeneous differential equation, yp is equal to negative 11 over 12 minus a half x. I can actually verify that. The first derivative I of our particular solution is negative a half. The second derivative is just obviously 0, which is equals to the third derivative. So if you plug in the derivatives and the y to the left-hand side of the differential equation, we must get 3x back. So this guy is 0. This guy is 0, negative 6 times 0 plus 11 times y prime, which is negative a half, and minus 6 times y, negative 11 over 12 minus a half x. So here you have, if you just combine these two, you get negative 11 over 2 and plus 11 over 2 minus a half x, and times 6 divided by 2 is, it must be equals to 3x, which is equal to 3x. So we just verified that this guy is a particular solution. Remember that since it doesn't have any C, it is a particular solution. It doesn't have any parameter. No parameter. So that's why we call it a particular solution. Just multiply P. At the same time, consider the exact same differential equation in homogeneous form. Consider the third derivative of y minus 6 second derivative plus 11y prime minus 6y equal to 0, the homogeneous form. Then the fundamental set is e to the x, e to 2x, and e to 3x. And actually check to see if it's the fundamental set by finding the determinant this way. E to the x, e to 2x, e to 3x, and the first derivative and the second derivative. Okay, we're going to write this determinant for a 3 by 3 matrix. You get e to the x, 2e to 2x, and 3e to 3x, and then e to the x, 4e to 2x, and 9e to 3x. This determinant becomes e to the x, parentheses, here we have 18, e to 5x minus 12, e to 5x minus e to 2x, parentheses, we have 9, e to 4x, and minus 3, e to 4x plus e to 3x, parentheses, here you have 4, e to 3x minus 2, e to 3x. Well, as you can see, these two will be opposite of each other. You have 6e to 6x, and here you have negative 6e to 6x. They're opposite of each other. You can cancel them out, and you're left with, here you have 4, 2e to 6x, which is not a 0. So the Wronskian is not 0. It means that these are linearly independent. So since the Wronskian of e to the x, e to 2x, and e to 3x is never 0, they are linearly independent. And that. So we have a fundamental set. So it means that the general solution using the fundamental set is y equals to c1 e to the x plus c2 e to 2x plus c3 e to 3x. Now that you have a particular solution, you have to combine them together. So the general solution for this differential equation, for this non-homogeneous differential equation, is y equals to c1 e to the x plus c2 e to 2x plus c3 e to 3x minus 11 over 12 minus a half x. So this is the general solution for non-homogeneous differential equation. The non-homogeneous differential equation.